Hi guys. So I'm going to do a couple problems from the practice problems and your study guide over the angle of elevation and angle of depression word problems. But before I do that, let's go ahead and talk about this problem. It was on PP 5.1 and it was on your quiz, but I ended up taking it off because a lot of you could not actually work it out. Well, and tell me why none of these are the right answer for this problem. Okay, so let's go ahead and draw the figure first. Okay, right triangle has the short leg. Okay, we'll call this the short leg, 15 feet. And an acute angle that measures 65. So the angles in this triangle are going to be 90 because it's a right triangle, 65. And the other one, when we can take, so whatever the other angle is, they have to add up to be 90. So I could do 90 minus 65. Because all the interior angles of a triangle equal 180, the sum of them. 8, 5. So the other angle is 25. So if we know that this is a short, then the angle across it from it is going to be the 25 degrees. And then this is going to be 65. Which of the following would not give the correct length of the hypotenuse? So you're trying to find, so these are all going to equal h. Okay. It looks like that you have to also find what the other leg is, x. And so the question is, which of the following would not give the correct length? So which of the following is not the correct length of the hypotenuse? So the answer was that all of these actually are the length of the hypotenuse. So let's go ahead and figure out what they get. The first one comes from using, you can tell whatever is after the tangent, cotangent, or the trig functions. Okay, that they're using that angle. And so if I use, let's see, sine of 25 degrees, which is opposite over hypotenuse, 15 over h, and if I solve for h, I'm going to get h times sine of 25 equals 15, and h equals 15 over sine of 25. So whatever has sine of 25 degrees, we know that this is right. So this actually is a proper way to solve for hypotenuse. Okay, cosine. Cosine of 65 degrees, cosine of 65, it's going to be adjacent of our hypotenuse. Okay, so h equals 15 over cosine of 65. So we know that this also solves for hypotenuse. Now, we get into an issue with these two. What you see is a square root, okay? And I'm going to take a look at this tangent here. Okay, so the tangent of 65 is opposite, which is x over 15. Okay, and then using that, you can solve for x. You can look for the other length. And when you see that square root, whenever I see a square root in a geometry problem, I always think something happened with a Pythagorean theorem. I don't know why, when I see a square root, like just like a coordinates, like square root of 2 over 2. Okay. Yeah, something must have involved the hypotenuse or the Pythagorean theorem, and it actually does, because it was a 45 when we knew the radius was 1 and we had to take the ratio. And all of that just involves the Pythagorean theorem. So whenever I see the square root in geometry, I always think somehow it's a Pythagorean theorem. So if I solve for x ends up becoming 15 times tangent of 65 degrees. So I can put that here. Okay, and then to find hypotenuse, it would just be the Pythagorean theorem, which is 15 squared plus 15 tangent 65 squared equals h squared. And when I square root both sides, you don't take the plus or minus because you can't have negative distance. But as you can see, that matches up with this right here. So this is actually the proper way to find hypotenuse using the information from the triangle. So take a look at the next one. The clue is this tangent of 25. So I'm going to go ahead and find the tangent, and this is no longer solve for x. This is the situation that we're in. Okay, tangent of 25 degrees. Tangent of 25, opposite over hypotenuse. Okay, so I'm going to solve for x. X equals 15 over tangent of 25 degrees. Now, once again, I have a different x value defined as a tangent. Okay, and then I'm going to use the Pythagorean theorem. So that's 15 squared plus 15 tangent of 25 degrees equals h, but we have to square root that. And that's the last one. So all of these give you the hypotenuse. So once again, the other leg could be expressed in the tangent of 25 and the tangent of 65. Okay, so we could have had it be 15 times tangent of 65, which also equals x. And hypotenuse, when I take all of the different angles and use all of the different sine and cosine and tangent and all of them, if I use all of them, like the trig functions, then I can create an equation to find hypotenuse. Okay? Good job. Okay, let's move on. I think these two were on your homework. Okay. It says here a surveyor is 85 meters from a bridge. The angle of elevation to the top of the bridge is 35. Oh, before I get started, let's talk about angle of elevation and angle of depression. And I did this in both of the classes. Here's my eye. So usually an eye is looking straight across. Okay. Now, the angle of depression is the change from that when you look down. Okay. So that is the angle of depression. So that's the measurement. Angle of elevation is the change of you looking at the horizon. This is looking at the horizon. Okay. And that's called the angle of elevation. How do you spell elevation? Oh gosh. I completely blanked out. Angle of depression, angle of elevation. Okay, starts with the E. Wow, Miss Alstrom. Now, one of the things that you may not know, if I draw a right triangle with the angle of depression right here, Okay, and if I draw another triangle, just like that, and I create a rectangle. Okay, notice that, whoa, what did I just do? Okay, notice that the angle of depression, which we could name theta, is congruent with that angle right here. And so now it's become the angle of elevation. Okay, so they're congruent, the angle of elevation and the angle of depression. So you can draw your angle of elevation, angle of depression in so many different ways. Okay, so let's do this problem. It says a surveyor is 85 meters from a bridge. The angle of elevation to the top of the bridge is 35 degrees. The surveyor's instrument is 1.42 meters above the ground. Find the height of the bridge to the nearest hundred. So it is very important that you draw this picture very well. So if this is the bridge and the surveyor is standing right here, and he's 85 meters away from that bridge. And let's say that's the top of the bridge. And he's looking up, and that angle is 35 degrees. Okay, so the surveyor's instrument is 1.42 meters above the ground. Find the height of the bridge. So this is also 1.42. So we need to find the entire height of this bridge, and that includes the 1.42 because the surveyor's instrument is higher. So the angle of elevation is only going to take into account the height, this height right here, because the angle of elevation, using that angle of elevation, you can find x, but you need a little bit more. You need the 1.42 because apparently he's using an instrument that's pretty tall. Okay, so that's his instrument right there. Okay, so whatever we get for x, the height right here, we know that we need to add 1.42 meters in the end. So here's the right triangle. There's the angle that we're using. It looks like these x and 85 are two legs. So tangent of 35 equals opposite over hypotenuse. So x equals 85 times tangent of 35. And remember, I want the exact values for these. Exact values involves just leaving it like this. You will not get a calculator be able to solve that because the calculators are also capable of giving you all the values of the unit circle. So we have 85 times tangent of 35 degrees plus 1.42 meters. And that's as far as we can go with that answer. Okay, if I want the exact value. And that's what I'll ask for. Okay, it says an airplane loses 2,000 feet of altitude every 15,000 feet it travels horizontally. So as an airplane is going horizontally, 15,000 feet, it's also losing altitude 2,000 feet. That's a linear function. Okay, and that's why it's like you can think of tangent as slope. You can think of tangent as slope. This is exactly a slope problem. Okay, how much, find the angle of elevation. Okay, find the angles of depression. Okay, so the angle of depression would be this angle right here, because once again, here is the horizon, and now you look down from it, or you move down from it. Okay, it would not be this angle because you would need a straight line, a horizon, and then you would need a change, which would be going down. So that's the angle. So the tangent of this angle equals, okay, opposite 2000 over 15. Okay, and then we can simplify some zeros, right? Tangent of theta equals 20 over 150. Wait a second, I can simplify another zero. So 2 over 15. Tangent of theta equals, okay, so the answer would be the inverse of 2 over 15. Okay, I had to edit out the video because I said something that I don't think I'm going to keep. I might put an angle problem when it has angle of finding angles with the sides given. But if I do, it would look like this. So theta equals, or you can say before I actually solve. So right here, it would say tangent of theta equals square root of 3. And that should be familiar to you. That should be familiar to you because you think to yourself, okay, that's in the unit circle. Now, most of these angles that we do, they're going to be outside of the unit circle, but that one is in the unit circle. Okay, so if I take a look, square root of 3 over 2, and 1/2 produces square root of 3. So y over x. So where is it 1/2 comma square root of 3 over 2? Well, when theta equals pi thirds, and when theta equals, is that the only one? Square root of 3. Oh, also it's tangent, so it's going to be, what is it? 5 pi over, no. What am I doing? Sorry, guys. I'm not, okay, so we're going to do 4 pi over thirds. And think about that line that goes from pi thirds all the way down. Okay, and you can think of reference angles if you want. Those are the two angles within 0 to 2 pi. Okay, and most of the time the plane could only be 60 degrees or 240 degrees. I would highly, it's inside the triangle, so you would use the one that's less than 180 degrees. So that would probably be a 60 degrees. You would have to use a 60 degrees angle. This doesn't work because that's 240 degrees. That can't be theta. That can't be inside of an interior angle. I mean, inside of a triangle as an interior angle. Okay? Nice. Okay, so I was doing this and in both of the classes. Hold on. And once again, the joy of word problems when you are in it. Okay, so Gunvaj is standing on a cliff on the edge, and his ocean spots a raft with Allison in it. Okay, his eye level his eye level is 18 meters. His eye level is 18 meters. Okay. Above sea level, and the angle of depression, I'm going to draw it down to the sea. Okay. The angle of depression right here is 7 degrees. So if you take that look, we created one triangle, and that's 18 meters. So I'm going to redraw that triangle right here to Allison. That's 18 meters and 70 degrees. He spots a shark at an angle of depression. So you have to go, oh, we're using 77 degrees. Oh, that's a, okay. In order to get to 12 degrees, you have to go past 7. So the shark is closer, okay, to the cliff. And here is the shark. And there's the water, and there is the shark with his, this is a horrible job. Okay, there's a shark, and that's 12 degrees. Okay, so if I draw another triangle right here, I'm going to bring that out. Okay, that's 12 degrees, right triangle, and that's still 18 meters. And if we look at the distance, and we're going to look at the distance because that's just the way that we created the triangle. Okay, if we look at Allison's distance right here, it's longer, so that's going to be A. And if we look at the shark's distance to the cliff right here, which is B, okay, we know that the distance between them is going to be A minus B. It's going to be A minus B. Okay, so remember, we need this in exact value. So A minus B. So let's go ahead and find A. We're going to use tangent. Tangent of 7 degrees equals 18 over A. And move these down. Okay, so that would be A times tangent. I'm just going to work it out. 18. So that's A equals 18 over tangent of 7 degrees. And then for the distance of B, it's going to be tangent of 12 degrees equals 18 over B. So that's going to be B over 18 tangent of 12 degrees. Okay, so A minus B. A minus B is going to be 18 over tangent of 7 degrees minus 18 over tangent of 12 degrees. And that right there, meters, is your final answer. That is your final answer in exact value. Okay, another fun little problem, and this involves Daniel and Lakeisha and Rava. Okay, let's see. Daniel is putting up holiday lights. He's putting up holiday lights, and this is his house right here. And his ladder is 15 feet at an angle of elevation. So its angle is put right here, 75 degrees. Lakeisha and Reva come by and pull the ladder out at the bottom 3 feet. Okay, that's very highly dangerous. Do not do this at home. Okay, you can literally, you can injure somebody And I guess he has one of those ladders that's not like one of those, like, that looks like that. It's just a straight one-sided ladder that doesn't give any support. I don't know what they're called, okay? I don't know the names of the ladders. Okay. But anyways. So they come by and they take, and it's the same ladder. So I'm drawing this completely, okay, out of what is that, scale, okay, off scale or whatever, okay, and then they come by and scoot it out. And this is highly dangerous. 3 feet, okay, and they don't tell you the angle of elevation or anything like that. Okay, so how do we find this? So I have 2 triangles. Okay, the one that they scooted out, and we know that the hypotenuse is 15. And look at this triangle. So it's going to be whatever A is from the pink triangle, this A distance right here. And it's going to be A plus 3. So that is going to be, bottom distance is going to be A plus 3. Now, the other triangle, they give you the angle of elevation, 15 feet. We know we have put a variable on that, and that's A. So let's go ahead and find A. It's going to be not tangent. Okay, I told B-Day that in most cases with angle of elevation and angle of depression, okay, I meant when it involves like eyesight, like when you're looking at something, okay, you're always going to use tangent. When you're looking at like visually seeing something, nobody measures the visual distance, but they do measure, when something is placed at an angle of elevation or angle of depression, that's different because we could actually take the length of that. Okay, Abdullah. Okay. And so let's find A. So it's going to be the adjacent over the hypotenuse. So what is that? So cosine? Is it co? Yeah, there you go. So cosine of 75 equals A over 15. And then A equals 15 times cosine of 75 degrees. I accidentally paused the video. I don't know why, but I think we were here. I think this was all written down, and then I erased everything because I was actually doing the rest of the problem without recording it. Always fun. Okay, so let's see. So we're gonna do cosine of 75. I think we already did this, but and that's adjacent over 15. So A equals 15 times cosine of 75 degrees. Okay, so it's asking for the height of the wall now. So I kind of drew this triangle incorrectly. This triangle right here, this figure right here. Let's redraw this figure to make it look right. So if they scoot, and that's over exaggerated, okay. If they scoot that ladder, okay, 3 feet out, it's going to also move it down to the wall, okay. And they're not asking for the original size of the wall. They're not asking for that. They're not asking for this right here. They're not asking for that. This right here. You can't even see that. But I think you can see my cursor. It should be in yellow. They're asking for the new wall height. So let's go ahead and take that A value that we found and add it to the green triangle because they're asking for this X right here, the new wall height that the ladder is on. And luckily, Daniel survived all of this. Daniel, you write a book. Okay. So we have 15 times cosine of 75 degrees plus 3. That's going to be your leg value. Okay, but it's asking for the other leg. So you just need to find use the Pythagorean theorem. And the Pythagorean theorem is going to be x squared equals 15 squared minus the other leg, which is 15 times cosine of 75 degrees plus 3 squared. So x equals the square root of 225, and you can leave it at 15 squared. I don't care. It's the same number. There we go. Good job. Okay. Challenge. Okay. This is probably the hardest problem because there's two parts. Okay, and Anurag and Anirudh are trying to find the height of a tree. Anurag determines the angle of elevation to the top of the tree to be 42 degrees. Anirudh measures the angle of elevation to the top of the tree to be 38 degrees. They are 200 feet apart from each other. How tall is a tree under the two different scenarios? So Anurag and Anirudh could be on both the same side of the tree, like due east, or the tree could be between them. Okay, so the first scenario is where here's the tree. And first of all, who is closer to the tree? So if I draw both of the scenarios, okay, let's see. The smaller the angle of elevation, the longer the distance is going to be. Okay, because this is, well, no. This is 42 degrees. Okay, and you can look at the length. Or okay, this is 38 degrees. Okay, and when it's 38 degrees, let me just draw the picture. Okay, here's the tree, and Anurag is 42. So to the top of the tree, the tree bigger. So that's 42 degrees. Okay, and the distance between them is going to be 200. And that distance, that extra distance, creates, from the same point, notice, it creates a smaller angle in that angle of elevation. I mean, you can visually see that. Not 200 degrees, but 200. What is it? 200 feet. That extra feet, that extra distance creates, and when I just did this, and those angles are not even to scale, but I just pick a point right here, where it should actually be here. Okay. On that tree that's perpendicular to this. And if I draw that angle versus that angle, you'll see the difference in the angles. That extra 200 feet creates a smaller angle, a shorter angle in that angle of elevation. Okay, so when in doubt, just draw a picture. And I mean, look at my drawings. I'm horrible at drawing, but I can actually interpret using the limited resources that I have of being an artist. Okay, I could look at it and I could determine. I can kind of determine which angle is going to be shorter. So the question is, how tall is the tree under the two? So we're going to look for the height of the tree. Okay, so we need to find x. Okay, let's go ahead and use a t for the tree. And so what do we know? We know that this entire distance is going to be x plus 200. So we have two triangles. One that looks like this, 42, and that's x, and that's t. And then one that looks like that, and this entire thing is x plus 200, and that's t, and that's 38. What do they have in common? They have the variable x in common, and they have the variable t in common, and we're trying to look for t. Okay, so I could say my answer is, tangent of 42 degrees. Okay, which equals opposite over, but that's two variables. Okay, we're in big trouble. Not big trouble, but we can say tangent of 38 equals t over x plus 200. Okay, and then you think to yourself, okay, this is a systems of equations problem, and I need to eventually solve for t. Couldn't I solve for t in both? Let's go ahead and solve for t in both of these. Okay, so t equals x times tangent of 42 degrees, and t equals x plus 200, all of that times tangent of 38 degrees. And then couldn't I set each of them, set both of these equations equal to each other since they both equal t? So x times tangent of 42 degrees equals x plus 200 times tangent of 38 degrees. Okay, and couldn't I just solve for x? Okay, so we have to distribute tangent into here. So x times tangent of 38 degrees plus 200 times tangent of 38 degrees. Collect the x's. Okay, and then factor out an x. Divide both sides by tangent. You end up with x equals 200 times tangent of 38 degrees, tangent of 42 degrees minus tangent of 38 degrees. Now we have x. We could use either of these equations right here or that one when we actually solve for t, we can use either of those equations using that what x is, and it just needs to have that substituted for x, and t could be, I'm going to use the first equation because it's the easier looking one. Okay, so t, using that equation, we have 200 times tangent of 38 over tangent of 42 degrees minus tangent of 38 degree, and that's times tangent of 42 degrees. We can't simplify because this isn't it's in a binomial, and that's just the final answer. Okay, and you can use the other one if you wanted to. It doesn't matter. You're going to get the same answer, but I just use this more simple. No, you're going to get the same answer. Yeah, you will. Okay, plus 200. You will, but you just have to put x plus. Anyways, I think that's it. Okay. Whoops. Oh. Now, B scenario is when the tree is in between them. Okay. And so we have, I'm going to draw a point right here. That's 38 degrees, and that is 42 degrees. And so that entire distance is 200 feet. By the way, this was in feet. Okay, so if I say that that's x, that distance right there, that splits that, then that should be 200 minus x. Okay. SAT problem. They always like to use this kind of like, variable. And so you end up with, we need to find the height. So h. So that's going to be tangent of 42 degrees equals opposite over hypotenuse. And then tangent of 38 degrees equals h over x. And you could do it, I could solve this one for h. H equals x times tangent of 38 degrees. And I could use substitution instead. I could just substitute this into h. X times tangent of 38 over 200 minus x. And then I'm going to multiply both sides by 200 minus x. So 200 minus x times tangent of 42. And that's x times tangent of 38. Distribute that tangent of 42, because tangent of 42 degrees is just a number. Okay? It's just a way a number gets expressed. Okay? X times tangent of 38 degrees. Collect the x's. X times, I just move this to the other side. Tangent of 42 plus x times tangent of 38. Factor out the x. Divide both sides by tangent of 42 plus tangent of 38. Okay, and I end up with x equals 200 times tangent of 42 over tangent of 42 plus tangent of 38. Okay. Now I'm going to just use that and then put it back into here to find h. H equals 200 times tangent of 42 over tangent of 42 degrees plus tangent of 38 degrees times tangent of 38. And you have to keep it like this. You can't, whoops, and that's in feet. That's in feet. And you can't simplify. Okay, you can't just cross these out. That's a huge no-no. Because this isn't a binomial. You have to factor out a tangent of 32 in this denominator right here. You have to factor out a tangent of 32 in just that denominator in order to cancel that tangent of 38 feet in the numerator. But the first term doesn't have a tangent of 38. Okay? So you can't do that. Okie dokie. I think that's all the word problems. Okay, this Honorug and Honorug on a ROG and on a root problem is something like this scale is not going to be on the test. Okay. But it's, you know, it's pretty rigorous and it's kind of fun. Okay. So bye guys.